BSc Chemistry, Organic Chemistry, SEC Second, Fuel Chemistry, presented by B. Madhav Narayan. Fuel chemistry is one of the important parts of petrochemistry where LNG, CNG, and biogas are covered. The contents of the topic: liquefied natural gas LNG, differences between LNG and CNG, advantages of LNG, biogas or gobar gas, production of biogas, biogas plant, manufacture of gobar gas, disadvantages and uses of biogas. First one, liquefied natural gas LNG. Liquefied natural gas is a natural gas predominantly contain methane CH4 with some mixture of ethane that has been cooled down to liquid from ease and safety of non-pressurized storage or transport. It takes up about 1/600th the volume of natural gas in gaseous state at standard conditions of temperature and pressure. LNG is odorless, colorless, non-toxic and non-corrosive. The liquefaction process involves removal of certain components such as dust, acid gases, helium, water, and heavy hydrocarbons. The natural gas is then condensed into liquid at close to atmospheric pressure by cooling it to approximately minus 162 degrees centigrade. Maximum transport pressure is set at around 25 kilopascals. Differences between LNG and CNG, liquefied natural gas and compressed natural gas. Compressed natural gas is often confused with LNG. Both are stored forms of natural gas. The main difference is that CNG is stored at ambient temperature and high pressure, while LNG is stored at low temperature and nearly ambient pressure. In the respective storage conditions, LNG is a liquid and CNG is supercritical fluid. CNG has a lower cost of production and storage compared to LNG as it does not require an expensive cooling in the process and cryogenic tanks. CNG requires a much larger volume to store the energy equivalent of gasoline or petrol and the use of very high pressure to about 3000 to 4000 or 205 to 275 bar. As a consequence of this, LNG is often used for transporting natural gas over large distances in ships, trains, or pipelines, where the gas is converted into CNG before distribution to the end user. Advantages of LNG. The primary use of LNG is to simplify transport natural gas from the source to a destination, usually which is across the ocean. It can also be used when adequate pipeline capacity is not available. LNG can be used to fuel internal combustion engine. LNG is in early stage of becoming a mainstream fuel for transportation needs. It is being evaluated and tested for over-the-road trucking, off-road marine and train applications. There are known problems with the fuel tanks and delivery of gas to the engine, but despite these concerns, the move of LNG as a transportation fuel has begun. LNG competes directly with compressed natural gas as a fuel for natural gas vehicles since the engine is identical. Advantages of LNG. Natural gas could be considered the most environmental friendly fossil fuel because it has the lower or lowest amount of carbon dioxide emissions per unit of energy and because it is suitable for use in high efficiency combined cycle power stations. For an equivalent amount of heat, burning natural gas produces about 30% less carbon dioxide than burning petroleum and about 45% less than burning coal. Now let us discuss biogas or gobar gas. Biogas is the mixture of gases produced by breakdown of organic matter in the absence of oxygen, that is called anaerobic condition. Biogas is a renewable energy source. In India, it is also known as gobar gas or dung gas because the main raw material is cow dung. Biogas is primarily contain methane and carbon dioxide and may have small amount of hydrogen sulfide, moisture and siloxanes. The gases methane, hydrogen and carbon dioxide can be combusted or oxidized with oxygen. This energy releases biogas to be used as fuel. It can be used for any heating purpose, such as cooking. It can also be used in the gas engine to convert the energy in the gas into electricity and heat. Now, important part is production of biogas. Biogas can be produced from raw materials such as agricultural waste, manure, municipal waste, plant material, sewage, green waste, or food waste. A biogas plant is the name of often given to anaerobic digester that treats from waste or energy crops. These plants can be fed with energy crops such as maize, silage, or biodegradable waste, including sewage sludge and food waste. During the process, the microorganisms transform biomass waste into biogas, mainly methane and carbon dioxide, and digest it. Look at biogas plant generally used in rural areas. In many rural areas, the electricity is produced through biogas plant. In the biogas plant, the degradation of biological matter by the bacterial action in the absence of free oxygen. The raw materials for biogas include animal dung, poultry waste, vegetable waste, waste paper, and cotton cloth, plant waste, grass, husk, leaves, skins, weeds, human excreta, birds' excreta, etc. Now I will explain manufacture of gobar gas or dung gas. Gobar gas is produced by the anaerobic degradation of cattle dung. It is carried out in a gobar gas plant which consists of a well-shaped underground tank called digester. It is covered with dome-shaped roof, both made of bricks and cement. The dome of the digester is fixed so that it acts as a gas holder for the biogas produced. At the top of the dome, there is a gas outlet pipe and a gas valve. On the left side of the digester, there is a sloping inlet chamber, and on the right side, there is a rectangular outlet chamber, both made up of bricks and cement. Fresh cattle dung plus water slurry is introduced from the inlet chamber, while spent dung slurry gets collected in the outlet chamber. The inlet chamber connected to the mixing tank while the outlet chamber is connected to the overflow tank. Now, how does the plant works? The slurry made by mixing cattle dung water in equal proportion in a mixing tank is fed into the digester tank via the inlet chamber till the slurry level becomes nearly equal to the cylindrical top level. In about 50 to 60 days, the biogas plant starts functioning. During this time period, the cattle dung undergoes fermentation in the presence of anaerobic bacteria with a gradual evolution of biogas, which starts collecting in dome shaped space. As the time passes, more and more biogas collects inside the dome, thereby exerting pressure on the slurry in the digester tank. This in turn forces the spent slurry to overflow tank via outlet chamber. From the overflow tank, the spent slurry is withdrawn periodically and used as a good manure. From time to time, the fresh slurry is fed to the digester so as to get regular supply of biogas. The biogas collected in dome is taken out the outlet pipe by opening the gas valve and then used as a fuel gas. The disadvantages of biogas and advantages of biogas you must know it. The advantages of the biogas production is very economical. It has been found that 1 kg of dry cattle dung gives about 160 liters of gobar gas, which can supply 800 kilojoules of heat. On the other end, 1 kg of dry dung on direct burning gives only 100 kilojoules of effective heat. Second one, the gas has all advantages of gaseous fuel like cleanliness, absence of smoke, and flexibility, etc. Number three, it does not contain poisonous gas like carbon monoxide as an ingredient. Next one, it provides simultaneously excellent yield of good manure. The disadvantages of biogas. Biogas can be explosive when mixed in the ratio of 1 part of biogas to 8 to 20 parts of air. Special safety precautions have to be taken for entering an empty biogas digester for maintenance work. It is important that a biogas system never has negative pressure, as the cloud cause an explosion. It is necessary to have the gas stove within 10 meters radius from the plant. The uses of biogas include one for cooking food, second one as a fuel to run engines as an invenant in villages. References, you can refer the best book Jain and Jain Engineering Chemistry, Dhanpat Rai Publishing Company, New Delhi. Also refer Wikipedia and sciencedirect.com.